Hi everyone, so this is the second part of the video. The next question is about thermal flask, or in this case it's called a vacuum flask. So before we even go into answer the question, we need to understand how this vacuum flask works. You have the plastic cap. I'm just going to highlight, you have to take note of what I say. Then you have the plastic cap. So you ask yourself, what is the plastic cap for? Why is it a cap? It's a cap to reduce heat loss by convection, because you don't want the hot air to rise up, right? So you reduce heat loss by convection, and the plastic is because it's a poor conductor of heat, it reduces heat loss by conduction. So wherever heat reaches the plastic cap, we try to reduce the heat conducted away from the plastic cap to the external environment. How about a glass with silvered surfaces? So there are two silver surfaces. One is actually in contact with the contents of the flask. The other one is on the other side. So we can't really briefly describe them because there are two surfaces here, one outer surface and one inner surface. Both same design, but both serve different function. And you have to state very specifically which surface reduce heat loss by radiation, which surface reduce heat loss by absorption. And a foam plastic support and a foam, as you can see here, air spaces in a plastic foam, in a foam plastic. So that will even suggest to you that it's a poor heat conductor. Now let's proceed on. How do you really answer the question? Now, explain the purpose of layer of vacuum between the silver surface in a vacuum flask. Now, most of you are able to tell me that is to prevent heat loss by conduction, but most people are unable to state that you also prevent heat loss by convection. Okay, but you have to take note that both conduction and convection require matter to take place. One solid, one liquid, and gas. So both require matter to take place, and hence both heat loss are greatly prevented. Sorry, it should be prevented, not reduced. Now explain how the silver surfaces of the glass help to keep the contents of the flask hot for a long time. As I mentioned earlier, there are two silver surfaces, the outer and the inner. And you need to read the question carefully. We're trying to keep the contents hot, right? So the contents hot. That means the inner surface reduce rate of heat loss by radiation. So that makes the inner surface a poor radiator of heat. So the inner surface reduce rate of heat loss by radiation. Sorry, you have to include here the inner silver surface. And the outer silver surface is a poor absorber of heat because it reduces rate of heat gain by radiation. So whatever heat that has been radiated out from the inner surface, you have to reduce its absorption on the other end. So hence the other end is a poor absorber of heat, also silver, and reduce the rate of heat gain by radiation to keep the heat within the contents of the vacuum flask. That's why I mentioned both have same design, but both serve different functions. Part C. Those of you who got it wrong didn't really elaborate on this. Many of you can say it's a poor conductor of heat. Good. You have to emphasize it reduces the rate of heat loss to the tabletop that the flask is resting on, or to the surface the flask is resting on. Mainly is to reduce the rate of heat loss, right? But I need to caution you all. Some of you went to use the word surrounding. Some of you went to use the word environment. Alright, no, we cannot accept that. That's too generic. When you say rate of heat loss to the environment, you try to picture this I take this answer, I can plug into any scenario. You have to answer in context to the question. So the context is the flask is resting on a surface, on a tabletop, on a chair, on a floor, whatever it is resting on, right? Using the word surrounding environment is very blunt, very generic, and can apply to any and every other situation. And basically what we call doesn't really answer the question.